Hey guys, this is Mrs. Munyon. We're working on the first Inquiry Lab of Chapter 2, Modeling Percents, on page 97. So how do we model a percent? Here's an example. Jackie is using 1-inch tiles, 1-inch tiles to make a mosaic, shown at the right here. Okay, she needs a total of 100 tiles. She needs 100 tiles in all. And what do they want to know? What percent of the tiles are green? Okay, so we can see the perimeter of this shape has green tiles. So what do we need to know? The percent of green tiles that are green. The percent of tiles that are green. What do we already know? Well, we know she's using 1-inch tiles and that she needs 100 tiles in all. 100 tiles. Okay, all right, so how are we going to count this? We need to be careful to remember that this is 10 by 10, but those two share this corner, okay? So I'm going to erase this really quick, and I'm going to think about how I want to count this without counting them all individually. And I think what I will do is I'll say 10, 20. So if I used this one and I use this one, that means there's 8 right here, right? So 8 and then 2 from this side, that's 30, 32, 34, 36. So there's 36 green tiles around the perimeter of this 100 grid. How can I use that information? Well, first they're challenging us here to represent those 36 tiles the way we would maybe normally do it if we were just filling out a hundreds grid. So let's do that in green. So we have 10, 20, 30, 32, 34, 36. Okay? In the mosaic, how many tiles out of the 100 are green? Well, that would be 36. So we could write that as a fraction. 36 out of the 100 tiles are green, or 36 hundredths. So if 36 out of 100 are green, that means 36% of the squares are green. Oh, yeah, that makes sense. Okay. All right. So here's some really important information. It will make your life easier if you become comfortable with these common percents: 1, 10, 25, and 33⅓%. Okay? Using these percents and their multiples makes mental math easier. And you'll start to understand what they mean by that as you explore these problems. So don't stress about that right now. Just know that those are common. Let's model 25%. So 25% means 25 out of the 100. So if we shade 25 out of the 100, 10, 20, 22, 24, 25. So it says shade the squares, filling one column at a time. Shade how many? 25 squares, because that's 25 out of 100 is 25%. What fraction of the 10 by 10 grid is shaded? Well, remember, the bottom number, or the denominator, is how many in all, and how many are shaded? 25. So 25 out of 100 are shaded. What's our next question? What decimal represents the shaded part? Well, if we read this, 25 hundredths, that means no holes, and 25 hundredths. All right, we've been doing a lot of work converting fractions to decimals, so I think you're probably pretty comfortable with that. A bar diagram is another way that we could represent a percent. So here it shows a bar diagram divided into 100% divided into 10%, so there's 10 squares. If we were to represent 40%, we would shade 4 of the 10. Now let's model 60%. 60%, the bar diagram below is divided into 5 equal sections. Why did we do that? Well, because 20, 40, 60, 80, oopsie, 80, 100, 5 20s add up to 100, right? 5 times 20, 5 times 20, 5 times 0 is 0, 5 times 2 is 10, yeah. 5 20s add up to 100%. So each section represents 20%. We actually wanted to represent 60%, right? 20 plus 20 plus 20 equals 60%. 20, 40, 60. That means we should shade 3 of the sections below. There you go. There is 60% of the whole. All right, why don't you go ahead and go try some on your own. I encourage you to work with another 6th grader if you can. And of course, come ask me questions if you need help.